Let's talk about negotiating an Ether channel for a few minutes and also see a negotiation in action. And with two separate Ether channel negotiation protocols, you know a question or two might pop up on your exam about the similarities and differences. I'm going to tell you a couple things you just need to memorize straight up about these two protocols in the next couple of minutes. Whether it shows up on your CCNA exam or a future exam, you're going to need to know this stuff sooner or later. Now, the industry standard Ether channel negotiation protocol, that's LACP, the Link Aggregation Control Protocol. The Cisco proprietary Ether channel negotiation protocol is the pain in the butt to type port aggregation protocol, PA, lowercase g, uppercase P. And while you might not like typing PAGP a couple hundred times in another book, you might love how the protocol dynamically changes all of the other ports in an Ether channel when you change a property of one of them statically, whether that be speed, duplex, or another setting. So you can see where that would possibly come in handy. And of course, anytime you change speed and duplex on one end of an Ether channel, you're going to need to do it on the other. Now, something else I want you to know about the LACP, it's probably a little beyond the CCNA scope, but you should know this. It's defined in 802.3 AD, and it assigns a priority value to each port with Ether channel capability. And you can actually assign up to 16 ports to an LACP negotiated Ether channel. And your immediate thought when you read that is, wait a minute, I thought we could only put 8 ports in. I understand, you can. Only the 8 ports with the lowest port priority will actually be part of the Ether channel. What you're doing in effect is creating backup ports for the Ether channel in advance, because the remaining ports would be put into the bundle only if one or more of the already bundled ports fails. So you would actually need something else to indicate to you, hey, this port just went down. Some kind of management device, because your Ether channel is actually going to stay at capacity, because one of these standby ports will step right into the role and be a primary bundled port. Now with PAGP, I would know stone cold PAGP and LACP and their modes. PAGP, the modes are desirable and auto. Now desirable, a port in desirable mode will initiate bundling with a remote port. A port in auto mode waits for the port on the other end of the trunk to start the process. Now, the thing is, if the ports at each endpoint are in auto, you'll be waiting forever. You really will. You'll be waiting forever, because they're each waiting for the other end. Each end is waiting for the other end to start the process. LACP, same thing, but different names for the modes. With LACP, we have active and passive, and that's pretty self-explanatory. Active is initiating, and passive is just sitting there waiting to be initiated upon, if you will. And if the ports at each endpoint of a trunk are passive, they will not join an Ether channel. It will never happen. So let's go ahead and bring the live equipment up and review those modes. We'll see them here with the channel group command. And by the way, the switches were initialized between videos, so everything previous is gone, referring to Ether channels. And let's go ahead and look at those modes again. We'll put all 4 ports in here. And we'll go with 2 again and mode again. And this time we are going to go with one of the PAGP modes. And we get the same channel group 2 mode auto. And the message about creating a port channel interface. Now, notice though, the line protocols have all gone down. That's going to happen when you don't use the on option. So you should see them a few seconds later come right back up. And we did just that. So let's go over to switch 3. Let's do the range thing again. Let's try that again. And channel group. We'll use 3 again, mode, and which one are we going to use? Let's try auto, see what happens. Port channel interface, port channel 3 is up, or it's been created, but we see the line protocols, the physical ones, all going down. We'll hang out here until they come back up naturally. And there they are. So we will run a quick show interface port channel 3. And, this is interesting, because we never did see a message about it coming up. The line protocols all came up, but notice now we have port channel 3 is down, line protocols down, not connect. We were connected a second ago because we saw the trunks at the very beginning of the lab part. So let's go over to switch 2. And we have down and down over here as well. But we saw the line protocols of the ports come back up, so that would seem to be certainly okay. Let's run show spanning VLAN 1. And this is interesting because you can see there's no bundling going on. All 4 of the ports are still seen as what we call standalone ports. They're just standing there alone. So let's see, what could we do? Maybe break out some of those show ether channel commands we looked at before. And this is interesting. We've got a brand new letter down here next to our ports. Actually, a couple of them, because port channel is shown as layer 2 and down. And that's not what we want. Down is almost never good. Now the protocol is mentioned here. Here's PAGP. And the ports are right here. And notice the code there is the letter I for standalone. So these ports are up and they are operational. And we could just verify that. We can run a quick show interface fast01. And you can see right there, up and up. And we saw the line protocols come back up after they went down. So physically, everything is fine. Logically, there's an issue. And I know you know what it is because you saw me do something that I just told you should never do, right? And that is that I put both ends of the ether channel into auto mode. That's exactly what the issue is. I wanted to show you this because this is what you need to look for. Whenever you see the letters I here, that means physically everything's fine, but logically there's a problem because they have not been put into the bundle. And the issue right now, and the reason they haven't been put into the bundle, is that both ends of the ether channel, every single port, was configured in auto mode. So switch 2 is saying, I think I'll just wait for the other switch to start the process. And switch 3 is saying the exact same thing. So that is not going to get us anywhere. We could come back an hour or a year from now and we're still not going to have anything to see as far as an ether channel goes. So what mode do we need to put these in without looking? Remember which one that was? If it's first time you've seen it, it's all cool. It's not something you got to memorize immediately. But I would have these down. Your LACPs are active and passive, and your PAGPs are desirable and auto. So if we put desirable here, we should get a desirable result. And the line protocols go down again because we made a change in the negotiation protocol. Now we see the line protocols go up and you see the port channel go up. It's really easy to take that for granted as far as the interface, the port channel itself coming up, because you see the line protocols, it's like, oh, okay, everything's fine, but everything's not fine. Whenever you put one of the negotiation protocols on, you've got to see the line protocols go down and then back up, of course, and then you've got to see the port channel come up. And just because I'm like that, pardon me, we'll do that as well. And you see show interface port channel 2. Port channel 2 is up, line protocol is up, connected, everything is beautiful. And the reason I also wanted to show you that, it's really easy to look at not connected in the paren and say, oh, okay, we must have a cable loose somewhere. I'm all for starting your troubleshooting at layer 1. Those of you who know me know that. So often the problem is physical. But the thing is, if the cables were just fine when we start a configuration and then 2 minutes later they're not, the problem is probably logical. So let's go ahead and run show ether channel summary here. And you can see now the ports are in the bundle. There's the protocol PAGP. Under port channel, we now see uppercase S and U, which means it's layer 2 and it's in use. And all 4 ports have been successfully bundled, as indicated by the letter P, bundled in port channel. And let's go ahead and look at that one more time. As far as I should know the word mode by now. Just be clear on which ones belong to LACP, which ones belong to PAGP. And if you worked with LACP, we're not going to do that because we'd really just be replicating what we just did. If you're running LACP and each end is configured for passive, you're going to see much the same result that we saw previously here, in that everything looks okay, but the bundling doesn't actually take place. So again, that show ether channel summary is a great place to start and check the status of your individual ports. That is all the ether channeling we're going to do right now. It's a great foundation for your CCNA exam success and those future studies as well. And we're off to another topic. Take a breather and I'll see you there.